Well, good morning, everybody. Welcome to Conversations on Critical Operations. Today we're going to be talking to Mark Jensen from TraPac. TraPac is a container terminal operator that operates terminals in the ports of Los Angeles, the Port of Oakland, and also operates terminals on the East Coast as well. Good morning, Mark.
Good morning, Nick.
And I'm Nick D'Orazio. I'm the senior media producer here at OSI Soft. This webcast is a production of OSI Soft. We're the makers of the Pi system. So let's start by just asking you, Mark, can you describe a little bit about TraPac? Tell us what it does.
Yeah, sure, Nick. As you touched on, TraPac is a container terminal operator, our flagship terminal being here in the Port of Los Angeles, where typically we've got two operational interfaces, one being our marine or waterside type operations, where we're loading and unloading containerized cargo from cargo vessels, and then we've got our landside operation where we're interfacing with over-the-road truck drivers and some of the railway operators in and out of the Port of Los Angeles.
Okay, and if I understand correctly, some of your equipment and your gear is absolutely state-of-the-art. And we have a video that I wanted to show, just to show people some stuff. Can you describe the different systems that you're using and kind of what they do for you at the port or at the terminal?
Yeah, sure, Nick. TraPac here in Los Angeles has invested very heavily over the last couple of years to electrify a lot of equipment away from the sort of the traditional container handlers towards automated straddle carriers. We've got automated stacking cranes, and we've also got an automated on-dock rail facility. So TraPac, I believe, was one of the first terminal operators globally to actually combine the autostrads, as we like to call them, with the ASCs, as we like to call the automated stacking cranes.
Okay, cool. And I wanted to ask you just what your role in all this was.
Yeah, so I'm the VP for Asset Management, which sees me overlooking essentially the maintenance departments for all that flash equipment, as well as the facility maintenance here. So that sees me have a number of different hats on. Facilities, we take care of things like the recycling, looking at the stormwater quality. So overall, it also sees me as being quite a champion for high reliability of equipment as well as for sustainability.
Okay. Who are your customers and what's important to them?
Yeah, mainly internal customers. Operations team being one of the biggest customer groups that I have, and they're looking for highly available and highly reliable equipment. When it comes to the facility side, obviously that's just about everybody here who's at the facility, who likes air conditioning, who likes having lights on. From an external customer perspective, my department also provides some monitoring and repair services to refrigerated containers and the clip-on gensets that they use.
Okay, and if I understand correctly, you were having just kind of the typical silos of information problem. You have these advanced systems, many of which have never been operated together before, certainly not been brought into Pi before. Can you describe what that was like?
Yeah, I mean, that's exactly the scenario that we had here, is that we've got a number of different, very different equipment types, actually, from different equipment providers. Some of those, I'll call it legacy equipment that we were operating in the terminal here before we underwent a bit of a transformation. And, the equipment from, with different manufacturers, there's different PLC brands, for example, on those. But it's not just typical traditional PLC equipment that we've got, operating in the business. We've got other software that we use for truck driver appointments, for example, and our various other terminal operating systems that we use here. And they're running on some, I'll say, a little bit less traditional, like a Java messaging service, a JMS, as opposed to some of the traditional industrial messaging that we have here. All these different systems, they're probably pretty good in isolation. But it is a complex automation system we've got here that has many interfaces, interactions between these different systems. And that's where we really were struggling as a business, is to see across that and the interaction between, one group of equipment with the next group of equipment, or, how the systems are actually, sequencing work correctly and things like that. And that's where you sort of got introduced to Pi through a consulting engineering firm who was helping us out. That was Hatch, bringing quite some good expertise in systems and process engineering, and I think they were pretty helpful with giving us some good ideas on how we could improve the way we were managing all that.
Yeah, and if I understand correctly, they were the ones, what do you call it, terminal operation system is the one that uses that, what was it called, CMS? Not CMS.
JMS.
JMS, uses the JMS protocol. We didn't have any existing interface for the JMS protocol, and they were the ones that ended up creating that interface.
Yeah, that's correct. I'm not really sure I know much about the gory technical detail on that one. But yeah, they've got a discrete transactional type message, and they're able to strip out the elements of that message and translate that into like the time series data, and then we're using a lot of event frames to actually then make sense of that and what that means for the cycling of our equipment, or the reservations that our equipment will make before occupying an area. Obviously we don't want two pieces of equipment trying to occupy the same area at the same time, because that would be a collision. So there's a lot of pretty pertinent detail there that they're stripping out of those messages.
Okay. Can you give an example of when you had all these systems and they weren't really talking to each other? I mean, we don't we like to stay positive here. You don't have to describe anything that was a big mess, but often there's a deficiency, there's a triggering incident, there's something where it's like, we're not communicating. This is not communicating as well as it could. Did you see any opportunities that you were really kind of looking for in this project, where you're saying, if we could just get these, just some examples of where not having all the information together in one place was a problem? I guess you've mentioned a couple of those along the way.
Yeah, Nick, I mean, I guess like any business, that we're looking to try and improve ourselves, to give better service to our customers. We are essentially a service business, and let's be candid for a moment that we were having, I'd say, very good days, and we'd have some days we'd rather forget. And what would end up happening in the wash up of all of this is that we didn't even really know what went wrong. On some of those days it didn't go so well, and also the days that went very well, we didn't really even know what went right. Imagine we're watching the big game, and I'm in the red jersey and you're on the blue jersey, and we didn't have the benefit of an instant replay to work out what just happened. And that's about where we were, and it was down to your strategic view that you had on the operation as to what was happening, or going right, going wrong. And we'd be having certain debates, maybe conversations, arguments, whatever adjective you really want to use there. And sometimes the strongest personality in the room would get their way. Sometimes the more senior person in the room would get their way. But we weren't necessarily targeting the areas of the biggest opportunities for us.
Yeah, Pat Kennedy, our founder and president, our CEO, he likes to describe how in operations it's so typical for, at a morning meeting, you spend the first 20 minutes arguing over whose spreadsheet is correct, if not the whole meeting. So that's one of the benefits that we've always seen about folks who, have come from a traditional area where everybody has to kind of bring their own stuff to a meeting. And you were having, you would have, I guess, things that were just, you were saying, not repeatable, good days that were not repeatable, and you would like to have something that was a little more consistent, right?
Yeah, absolutely. That consistency, predictability, based on the good things is how we're going to continuously improve there. So that's definitely desirable for us to do that.
Cool.
And you touched on it very well there. Is everyone's got their own version of the truth. we need to have one version of the truth.
Okay, cool. Now, one of the things that let's just start talking about your data structure now. So you're not with a lot of our customers are in a traditional batch-oriented world, like pharmaceuticals, right? They're making batches, and it's repeating cycles, and they compare cycles, and they use RFN frames from that. What you're doing, though, ends up lending itself very well towards comparing things using event frames, because what you're doing is very much involved in cycles, right? Can you describe that?
Yeah, Nick, that's exactly right. So, from a definition of a cycle, for example, if we were to consider an import container, that the ship-to-shore crane would lock onto the container on the vessel, it would bring it ashore, it would detach from the container, ending the ship-to-shore crane cycle. That container would have been in a handoff zone, which is then going to be collected from our horizontal transport, or the autostrads, which would then commence like another cycle for the autostrad to transfer it to our stacking space in the yard, which would then, that would be a discrete cycle on a different type of equipment. We'd have the same for the stacking crane in the yard to collect from the transfer point to put it into the storage area. And then when the trucker arrived, the stacking crane would retrieve the container from a storage area and deliver it to the trucker. So you've actually got 4 discrete phases or equipment cycles in there, or we would also call those transactions in our business. So, very, very highly transactional based way of working. We will do that, thousands of times a day, moving containers backwards and forwards.
Okay, and when you were able to bring all that as discrete cycles or events, as we call it in AF, when you were able to bring that into Pi, you could then use other tools like Microsoft Business Intelligence, BI, and other things. I've seen some interesting stuff. I got some stuff I wanted to show, like this right here.
It should be looking at some ship-to-shore crane discharge cycles.
Yeah.
More specifically, we've got some single lift cycles up the top there. And if I draw your attention, there's like a yellowy cover bit of the box in the middle there, which is only present on some of the cycles. And that's where we're deconing the containers. The cone's being a device that interlocks the containers when it's on the vessel. When we bring it ashore from the containers or the boxes that are on deck, we remove those cones. We store them temporarily. And when we're backloading export containers, we would reinsert those to secure them on deck. When we're working below deck, retrieving containers from the hold, we don't have those interlocking cones, so we don't need to remove them. So the yellow is the contribution there for single lift cycles, for example, of removing the cones. Now, a number of the ship-to-shore cranes I've got operating here at TraPac, they're actually twin lift ship-to-shore cranes, which means that if we've got the right working conditions on the vessel and the right stow plans, we're actually able to pick 2 20-foot containers simultaneously and then run it through the cycle, which, a little simple bit of intuition would tell you, hey, you're moving 2 containers in one cycle instead of 1 container. That seems really attractive. So we've got two things on the graph there. As we can see, again, it's going to be intuitive that you're landing on 2 containers, that it's going to be a little bit harder. So you've got a bit of a thicker dark green section there on the one at the lower bars there, which is where the crane operator is moving towards the target containers and attempting to land. And then you've got slightly longer cycle times because you've got 8 cones to remove instead of only 4. The 2 boxes are going to be heavier than 1, so the crane is a little bit more restricted in the hoist and the travel speeds. But this data is actually, I think, very, very interesting. That I remember, much earlier in my career, the question about whether the premium for twin lift cranes over single lift cranes was ever going to be worth it. And this set of data here is actually very, very helpful in seeing, what the cycle time penalty is for twin lifting. And you can see it's maybe it's a 20% cycle time penalty, maybe it's a bit less. But the fact that you've moved 2 containers in slightly longer time instead of twice the time, we're actually much better off from a cycle time or an overall throughput perspective.
Okay. So one of the things that I know you presented this at your Pi World online presentation this year, and also I think back in 2018, you had such a variety of charts like that. You had heat maps that were really just kind of fascinating in what things you were able to determine. How did you develop those? Who ended up creating those displays? Did you have a process? Did you have a way for somebody to submit ideas? And did you have to add anything? Did you have to add new instrumentation? Did you realize as you were working through this, there's some things that were missing? Just how did you come up with this? I mean, if you look at your full presentation, just this cornucopia of absolutely fascinating visualizations that taught you things that are very straight. I mean, I don't know anything about terminals, but I was fascinated by your process because the data made it look so interesting. But how did you go about doing all that?
Yeah, Nick, it's actually it's a long and hopefully interesting story, that one. So we go back to the very beginning with all that. So we were in the state that we were in, and Hatch recommended that we give this a go. And as a business, we started upon a bit of a proof of concept, and I think that was intended to run for about 12 weeks. And part of the scope of that proof of concept, there was certain data that we were targeting, which was certain fault information, and I'll say certain other basic telemetry, like a locational XY type GPS coordinate of certain equipment. So pretty bare bones basic stuff. So we started collecting that as stuff that we felt was going to be useful. Maybe not really knowing where we were going to use it. But it didn't take very long once fault code or warning type information started becoming available to us in a manner that we could, it was logged, it was organized, it was time stamped. We knew what equipment happens, where it happens, all that very, very good information to have. Things like those Pareto charts were just the logical and the natural next step for that. To start to understand where our pain points were, how much more significant they were. But then there was two things that started to come very quickly from those Pareto charts, and the obvious one is to start directing efforts, particularly in maintenance, towards certain corrective maintenance activities that were causing the most operational grief. The low-hanging fruit, so to speak. But then the other sort of thing that started coming out of that was that once we knocked off a few of those low-hanging fruit and identified and corrected certain specific machine, like to an individual machine, we had other I'll say fault conditions that persisted or continued. Now with those autostrads, just to give a more precise example of that they've got like a in-ground magnetic array that helps them with their navigation as some checks to go with inertial units and GPS and other LiDAR type systems. And what we were finding and getting actually incredibly frustrated by, to be honest, we were getting faults with the magnetic system that were false or fail to detect magnets when it was expecting to detect magnets. But this wasn't just on just the one unit, it was virtually every single unit in the fleet. It was getting, as I said, incredibly frustrating because we would bring machines in, we would troubleshoot, we would probably find there was nothing wrong with them, scratch our heads, repeat the process tomorrow. But then, the fact that we had other telemetry on that, this is where the heat maps were born, is we became, for certain fault conditions like the missed magnets, for example, we started becoming less concerned about the equipment and more focused on the locality in the terminal that fault was occurring. And it didn't take very long in taking that approach to see that a lot of these fault conditions that were happening to every single piece of equipment in the fleet were happening in the same grid coordinate system out in the terminal, which would lead us to a magnet that had become faulty or deficient or was missing or something like that. And of course, instead of trying to fix the machine, fixing the missing magnet in the facility actually would then help us to correct that fault. So all of that we were able to do without installing any additional instrumentation whatsoever. That was all based on just exposing certain data tags within the equipment that we had out there. Being it's automated equipment, it was connected back to central PLC equipment or other server devices. So we didn't even need any sort of data transition medium. It was already there to piggyback on the back of. But as we continued with some of the successes with this, and these clever things that we were doing, we're still running a whole fleet of pickup trucks and other equipment on site, like buses to move people about. We've got small forklifts, big forklifts. I've got man lifts, and a container terminal is a big place. We looked for a solution and actually found some devices that I could install to the engine diagnostic ports. Like it's an OBD, onboard diagnostic port too. It's been a mandated requirement for many years for a lot of vehicles to have those. And this little device, picks up the power from the diagnostic port, and it gives a GPS location on the like a pickup truck or one of our buses, and I'm actually able to transmit that through the LTE network back to a cloud service and connect that into Pi as well. So that gives me some other great data opportunities there as well.
That's very cool. Actually, was that even planned in advance, or was that just something that you stumbled onto? And the reason I'm asking that is because I'm imagining that as you're going through in a project like this, once you have the data and you start developing these displays, some things are going to work out real well, and then some are going to be like, well, that was a big waste of time. And that's a visualization that just completely fell flat. I thought it'd be useful, but it ends up just being noise or whatever. But did you end up with a bunch that didn't, just to give people an idea when they're trying this themselves, did you end up with a fair amount of chaff that you're just like, nice try, but it didn't really work out?
To be honest, no, not really. That we were very successful with the proof of concept, and that was the bare bones startup of this. That there was not a lot of bloatware out of the box on this one. So there's nothing that wasn't sort of purposely prepared. And when it came to that example of the OBD2, that if you'd asked me at the start of the project, or either pilot phase, was this something that I had on my radar? No, the answer is no, it wasn't. That it's something that one success has led to an idea that's led to another success, and we've been on a bit of a virtuous cycle with that. So I can very honestly say that there's been nothing within Pi that we've gone, that wasn't a good idea, I'll delete that and start again. It's been plenty of things superseded though by better ideas or better ways of contextualizing or visualizing data though, but nothing we've deleted out of the system.
Okay. And Hatch was the engineering firm you worked with on a lot of this stuff. I guess were there, what's it been like working with us? What's it been like working with an engineering firm? Just working with the software in general.
Yeah, well, the Hatch team, I think that they were very good partners, definitely early on this. That they had some very good experience, and they were probably very instrumental in the very early success of the product. And then just as it's continued on and being introduced to the Pi worlds, I mean, I did manage to attend the conference a few years ago, and I mean that was actually really great experience to just see what other people are doing and what better looks like. Maybe see how far behind we actually are some of the other industries in using this, which being that I think that TraPac's the first container terminal to be using this software as well, it makes me also maybe feel good that we're starting to leave our some of our other industry brethren behind as well. So
cool.
Yeah, interesting stuff.
Okay, so any lessons that you learned in the process? Is there anything that you would want to suggest to people who are maybe thinking of going down this path themselves?
Yeah, I mean that obviously having some good partners is probably a pretty good first step, and understanding what it is that you want to get out of the system at the end. which then leads to being very deliberate in the way that you might set up things like your asset hierarchy and the data that you're capturing. That then leads to the event frames or subframes, and then on to the actual maybe dashboards or reports that your actual end users are going to be using. That as much as I'm a big fan of a lot of this data, that it needs to be in a context that's useful. And useful means it needs to help drive good decisions. So that's the other one is this data is really about empowering people to make good decisions. So that would be
cool. Oh, that's cool. Now stick around. We're just about finished. I only have a couple more questions, and I have a lightning round that I want to throw a bunch of questions at the end. So stick around for that. Benefits. What kind of benefits have you been able to get from doing all this?
Yeah, well, certainly for my function in maintenance, we're getting a lot of very valuable information, which does help us with making better decisions when it comes to repair decisions on equipment. So as an overall business, though, what does that mean? That if we've got more reliable equipment, we've got more available equipment, it helps us with our overall productivity or throughput, which means that we're giving, ultimately we're giving better and more predictable service to our customers, whether it's our marine customers, our road customers, or our rail customers. And then the other thing that just stems on that too is that as we continue to understand our operation better, make better decisions, becoming more predictable, which means we're becoming more efficient. Efficiency being a big thing too towards our desire to be very, very sustainable. That if we can operate the equipment a little bit less, or if we can make a little bit more of efficient routing within the terminal, then we're consuming less resources, which ultimately is making us more sustainable. And we can I can't fight that data. That's something we keep very close to our chest, but we're definitely seeing reliability improvements are sustained, and as well as other operational metrics that are systemically improved.
Okay, so I guess any plans for the future? Do you have a next step that you're looking forward to?
Yes, something that I'm watching really closely is what's happening in like the artificial intelligence, machine learning world out there. That we've got a lot of very good reports, a lot of very smart people who look at the data. We're getting a lot of very good knowledge in interpreting the data and understanding what some of the patterns in the data might mean. But it is a manual process, and it's looking for a needle in a field of haystacks, so to speak, and that can be sometimes a little bit slow to identify these corrective maintenance opportunities. And I'm watching that AI ML world closely because that having the opportunity for a computer to recognize these patterns and maybe present them to a user instead of making the user find it themselves, could maybe speed that up. And what that means for my team is that we're identifying corrective work faster, which means we're executing it faster, and then delivering more reliable equipment back to the business faster.
Great, thank you so much. Well, look, if you joined us late, you've been watching Mark Jensen from TraPac. We've been just talking about what they've been doing in critical operations at TraPac at their terminals. The ports of Los Angeles and others that they manage. I got a bunch of questions I just want to throw at you real quick, if you don't mind. Are you game for that?
Yeah, bring it on. Let's have fun.
Okay. Are you right now wearing steel-tipped shoes?
No, they're carbon fiber.
Touche, that's good. How about fireproof clothing?
No.
No fireproof clothing. Okay, good. But you got the vest. I like the vest. It's very cool. What's the best food item you can buy at your location? I assume you guys have a cafeteria or something there, or vending machines. What's the best food item you can buy?
I like the Polish and egg breakfast sandwich off the van that comes through.
Very cool. Okay. What's the coolest calculation you've ever done? Let's put you on the spot. We haven't discussed this before. I know it's putting you on the spot, but what is the coolest? Do you have one?
Can we go calculation, or do you want like a spreadsheet?
Calculation or spreadsheet? Yeah, a report. Just some use of data.
Yeah. I mean, I've been doing some stuff with projecting maintenance preventative work at the moment. I was very, very satisfied with myself with what I came up with. So that's definitely
cool.
in front of my mind at the moment.
Cool, cool, yeah. How about what's the first computer you ever used?
Oh, I remember it was a 4-color, with the 5 1/4 floppy thing. I don't remember the name of it, but
okay, cool, cool. Do you go off-site for lunch less often than you did 20 years ago?
No, probably about the same. I tend to bring leftovers or 2-minute noodles, little tins of tuna and stuff like that.
Okay, what's your favorite view at your physical location? What is it you're looking at?
The window behind me is actually looking out over one of the workshops that I've got here. I wouldn't say that's my favorite view. It's working the ports, usually you've got a pretty good view over the waterfront somewhere. So normally I probably want to try and get out on maybe a crane and get a good vantage point up there.
Oh my goodness, yeah, I was looking at your video, the video, and it's like, man, this is just like, this is very cool. I was used to stomping around sodium plants, not particularly interesting. Let's see. Are there any words? No, let's save that for last. How many passwords do you estimate you have to enter every day?
Too many.
Good answer. Are there any words you avoid when you describe what you do for a living?
Guess would probably, guess or guesswork would probably be what I'd try to avoid. Yeah, but isn't that the old, engineering thing? It's about precision guesswork.
Right. Okay, and finally, how often do you miss lunch?
Probably 2 to 3 days a week. But I don't miss it. I just miss the lunch time. Usually, I'm trying to get something in by about 2 o'clock. Otherwise, I'm passing out.
Well, I really appreciate you taking the time. Thank you so much for talking to us.
Yeah, no, you're welcome, Nick. It's been a pleasure.
Great, thanks. So, if you've joined us late, you've been watching. This is Conversations on Critical Operations. We've been talking to Mark Jensen from TraPac. Please, I hope you join us for more of this series. We're going to be talking to, and we'll be doing this live. We'll be talking with David Trombley from UC Davis. He's going to be talking all about how our facilities, or how at their facilities at their large university, they've been using the PI system to optimize on things like energy management. So, well, thanks again for joining us, and see you all next time, and stay safe out there. Bye-bye.